A nebula in space is a vast interstellar cloud of dust, hydrogen, helium, and other ionized gases, acting as cosmic recycling factories, where new stars are born, like the Orion Nebula, or remnants of dead stars are found, like planetary nebulae, or supernova remnants, like the Crab Nebula. These clouds glow, often in vibrant colors, due to energy from nearby stars, or the dying stars themselves, revealing beautiful structures that can span light years, though the intense colors in famous photos are often enhanced. A nebula is a distinct luminescent part of interstellar medium, which can consist of ionized, neutral, or molecular hydrogen, and also cosmic dust. Nebulae are often star-forming regions, such as the pillars of creation in the Eagle Nebula. Some may think of galaxies when talk about nebulae, but in reality, a nebula is a cloud of cosmic dust and gas within a galaxy, often a stellar nursery for new stars, while a galaxy is a massive gravitationally bound system containing billions of stars, gas, dust, planets, and dark matter like our Milky Way. The key difference is scale. Nebulae are much smaller components inside galaxies, which are vast cities of stars. A nebula is primarily a giant cloud of interstellar dust and gas, mostly hydrogen and helium, but also contains heavier elements like carbon, oxygen, nitrogen, and trace amounts of other elements like sulfur, neon, iron, and solid dust grains, varying greatly by type, such as star-forming, planetary remnant, supernova remnant. These components, sometimes ionized into plasma, form complex structures that are key sites for star birth and galactic chemical enrichment. Gas makes up about 99% of a nebula's mass, and dust accounts for the remaining 1% of the material, and is composed of tiny solid particles. The specific composition can vary, depending on the type of nebula, like planetary nebula, supernova remnant, or diffuse nebula, and its evolutionary stage. These elements, particularly carbon and oxygen, are crucial for chemical enrichment of the galaxy, and the formation of new stars and planetary systems. The composition of a nebula is determined by spectroscopy, which is the study of how light or electromagnetic radiation interacts with matter, analyzing the absorption, emission, or scattering of different wavelengths to reveal a substance's chemical composition, structure, and properties. A nebula does not have an atmosphere like a planet, but instead, a nebula's atmosphere is an extremely diffuse cloud of interstellar gas, mostly hydrogen and helium, and dust, vastly thinner than Earth's air, with densities as low as a few atoms per cubic centimeter, but with denser clumps, where stars form, featuring varying temperatures, from near absolute zero to millions of Kelvin, and pressures due to stellar winds and radiation, creating dynamic structures like pillars and bubbles. It has some gas pressure, especially in star-forming regions, where densities can briefly approach Earth-like conditions. Nebulae are soupy vacuums, far too sparse for breathing or atmospheric effects, but contain the building blocks for stars and planets. In essence, think of a nebula as the ultimate space, a vast, cold, diffuse cloud, not a breathable layer of air, but the raw material for creating planetary atmospheres and stars. There are 5 main types of nebulae, and those are emission nebula, glowing ionized gas; reflection nebula, dust reflecting nearby starlight, often blue; dark nebula, dense dust blocking light; planetary nebula, shells from dying stars like our Sun; and supernova remnants nebula, expanding clouds from exploded massive stars. These categories describe how nebulae interact with light and their stage in a star's life cycle, from stellar nurseries, emission or reflection, to stellar graveyards, planetary or supernova. Other classifications include diffuse nebulae and protoplanetary nebulae. Emission nebulae are glowing clouds of ionized gas and dust, primarily hydrogen, that emit their own light, often appearing red, due to hydrogen alpha emission, caused by intense ultraviolet radiation from nearby hot, young stars, exciting the gas. They are vital, stellar nurseries where new stars form, with classic examples, including the Orion Nebula, Lagoon Nebula, or Eagle Nebula, and serve as cosmic beacons, glowing as long as their central stars shine, eventually dispersing or becoming planetary nebulae as stars die. They are found in active star-forming areas or around aging stars, and often appear as vivid red, but can show other colors depending on chemical composition. A reflection nebula is a cloud of interstellar dust that appears luminous because it reflects light from nearby stars rather than emitting its own light. These nebulae typically look blue because the dust grains scatter shorter, blue wavelengths of light more efficiently, similar to why Earth's sky is blue, with famous examples including the Pleiades, M45, and the nebulosity around the star Merope, NGC 1435. Unlike emission nebulae, the stars illuminating them aren't hot enough to ionize the gas, but their scattered light reveals the presence of dust. They are often found in star-forming regions where new, bright stars are born. A dark nebula, or absorption nebula, is a dense cloud of interstellar dust and gas that blocks visible light from objects behind it, appearing as a dark patch against the brighter cosmos, crucial for star formation, with examples like the Coal-Sack Nebula, Barnard 68, and Horsehead Nebula. These clouds are composed of tiny dust particles, including frozen carbon monoxide, absorbing light at visible wavelengths, and creating silhouettes where new stars are born. Dark nebulae are challenging to observe due to their darkness, requiring clear, dark skies away from light pollution. They are best seen when they obscure bright background objects, allowing their shapes to stand out as voids in the starry background. A planetary nebula is a beautiful, glowing shell of gas and dust, cast off by a dying, sun-like star during its final evolutionary stage, revealing the star's hot core, a white dwarf, and enriching space with heavy elements like carbon and oxygen. Despite the name, they have nothing to do with planets, a misleading term from early astronomers who thought they looked like planetary disks. These short-lived cosmic clouds are formed as stars between 1 to 8 solar masses gently expel their outer layers, creating stunning, complex shapes that glow from the central star's ultraviolet radiation, offering a glimpse into our own sun's future. Famous examples include the Helix Nebula, or Eye of God, Cat's Eye Nebula, and Ring Nebula. Planetary nebulae are fleeting, existing for only tens of thousands of years before the gas disperses, making them rare compared to stars. A supernova nebula is a supernova remnant, the expanding cloud of gas and dust left behind after a star explodes. This expanding shell of material is formed by the shockwave from the explosion and is rich in heavy elements created during the star's life and death. The shockwave sweeps up and heats the surrounding interstellar medium, or gas and dust, causing it to glow. A supernova remnant can contain the leftover core of the exploded star, such as a neutron star or a black hole. Famous examples of supernova remnants include the Crab Nebula, the Veil Nebula or Cygnus Loop, and Kepler's supernova remnant. A diffuse nebula is a vast, irregularly shaped cloud of interstellar dust and gas, mostly hydrogen, that lacks defined edges, acting as cosmic nurseries for new stars and stellar systems, and includes types like glowing emission nebulae, starlight reflecting reflection nebulae, and light-blocking dark nebulae. They are the most common type of nebula, often found in spiral arms, where gas and dust accumulate, with famous examples including the Orion Nebula. A protoplanetary nebula, PPN, also known as a preplanetary nebula, is a short-lived astronomical object that represents a critical transitional phase in the life cycle of intermediate mass stars, such as our Sun, as they evolve from the asymptotic giant branch, AGB, into a planetary nebula. The PPN phase is extremely brief in astronomical terms, lasting only a few thousand years. Nebulae have vastly different lifespans, from a few million years for protoplanetary disks, like our early solar system's nebula, to a mere 10,000 to 30,000 years for planetary nebulae, which are brief, death throes of stars like our Sun. In contrast, giant star-forming regions, like the Orion Nebula, can persist for millions of years by creating many stars, while supernova remnants, like the Crab Nebula, can glow for millennia until dispersed by stellar winds or shockwaves. A nebula's lifespan depends on its type, mass, and the energy driving it. Planetary nebulae are fleeting because the central white dwarf's radiation eventually spreads the gas too thinly, while star-forming regions are massive and dynamic, taking much longer to evolve or disperse. Protoplanetary nebulae or solar nebulae are the clouds that form stars and planets, like our own, lasts for a few million years, 1 to 4 million years for the solar nebula, before collapsing into a star system. Planetary nebulae are the glowing shells of gas from dying sun-like stars with or less than 8 solar masses. They are very short-lived, shining brightly for only about 10,000 to 30,000 years before the gas disperses. Star-forming nebulae, or giant molecular clouds, are vast clouds of gas and dust, can exist for millions of years, continuously forming new stars, though they are eventually disrupted by the formation of massive stars and supernova explosions. Supernova remnants are nebulae formed from massive star explosions, glow for many thousands of years, but their material eventually mixes into the interstellar medium, often within a few million years. A nebula's life cycle is the birth and death of stars. It starts as a vast cloud of gas and dust. Gravity pulls parts together to form a dense protostar, which ignites into a shining main sequence star, eventually expanding into a red giant or supergiant, and finally dying as a planetary nebula, for smaller stars leaving a white dwarf, or a supernova, for massive stars, leaving a neutron star or black hole, with its material enriching space for new nebulas and stars. The life stages of nebulae are stellar nebula or birthplace, protostar, main sequence star, red giant or supergiant, death, which is vary by mass, and recycling. Stellar nebula or birthplace stage is a giant cloud of hydrogen gas and dust. Gravity starts pulling clumps together. Protostar stage is where the collapsing clump heats up and spins, forming a hot, dense core. At main sequence star stage, nuclear fusion begins in the core, turning hydrogen into helium, and the star shines steadily, like our Sun. Red giant or supergiant stage is when hydrogen runs out, the core contracts, and the outer layers expand and cool, glowing red. Death of a nebula varies by the mass. Low or medium stars, like the Sun, shed outer layers as a beautiful planetary nebula, leaving a dense white dwarf that cools into a black dwarf. Massive stars explode in a violent supernova, leaving behind an incredibly dense neutron star or a black hole. At the recycling stage, the scattered material from dying stars form new nebulas, starting the cycle anew, creating elements essential for life. Thank you for watching this video. I hope everyone learned something new about nebulae. Please make sure to subscribe my channel. Thank you.